What's up, class? My name's Sam, that's Steven, and that's Fabio behind the camera. And today we're going to learn about expected value. Expected value is the predicted value of a variable outcome. For example, find the expected value of a game of blackjack.
House always wins.
To calculate the expected value, we take the sum of the outcomes of each probability multiplied by the probability of that outcome. This sounds complicated, but it's actually quite easy. We'll explain later.
You may have come across expected value before if you ever taken in statistics or in investments class because this topic often comes up. Another real life example is when you're playing a game such as gambling. Let's start off with a simple problem. Think back to your childhood and when you lost your first front tooth. That means it's tooth fairy time. But let's just say the tooth fairy sometimes can be cheap. Let's suppose sometimes the tooth fairy leaves $1 half the time and 50 cents the other half the time. What's the expected value?
So the first step here is to determine what the two outcomes are. In this case, it's going to be 50 cents and $1. Now we identify that there's a 50% chance of each outcome being the outcome that the tooth fairy leaves us. So we're going to multiply by 0.5 and 0.5. Now we have to solve the equations that we have for ourselves. We do 50 cents times 0.5, which is going to give us 25 cents, and 50 cents. The last step is to add both of these together, which is going to give us 75 cents. By doing this equation, we can find out that the expected value is 75 cents.
So what does it mean to have an expected value of 75 cents? We know their two outcomes are 50 cents and $1, so we'll never actually get 75 cents. What an expected value of 75 cents means is that if the tooth fairy were to come many times, then on average, we could expect to receive 75 cents per visit from the tooth fairy.
So that last tooth fairy problem is kind of basic because there was only two possible outcomes. We're going to try it one more time with three possible outcomes. So now we're going to be trying it with 50 cents, 75 cents, and $1. Let's say that there is a 25% chance that we get 50 cents and a 25% chance that we get 75 cents, and then 50% chance that we get $1. So we're going to do the same process, multiply all of these, and for this one, we're going to come out with 0.125. And for this one, we're going to get 0.1875. And for the $1, we're going to come out with 0.5. Now we're going to total all of these, and we're going to get 0.8125. And that is the expected value.
Another topic in expected value is Newcomb's paradox. Newcomb's paradox involves a choice between two boxes. In box 1, you have $1,000. In box 2, you have either $0 or $1 million. But here's the thing, you can only take both boxes or take just box 2. So you have your two boxes, $1,000 in box 1 and $1 million or $0 in box 2. But here's the thing, there's a psychologist in the room who guesses what you're going to take with 90% accuracy. If he thinks you're going to take just box 2, he's going to put $1 million in that box. If he thinks you're going to take both boxes, he's going to put $0 in box 2, leaving you with just $1,000.
So, if you're in a situation like I am, you got to come up with a lot of cash, but your bookie doesn't take off your kneecaps.
So how can we use expected value to make sure that Steven keeps his kneecaps today? So that we know there's a 90% chance that the psychologist was correct. So let's use this equation. 0.9 for the 90% chance times $1 million plus 0.1 for the 10% chance times 0 for the $0, which gets us $900,000. So right here is the expected value of taking just one box. Now let's calculate the value of taking both boxes. So we have 0.9 times 1,000 plus 0 plus 0.01 times 1,000 plus 1,000,000, which equals $101,000. So based on this, what's the best option?
Take box two, big money, big money. Come on, let's go. We need the million. We need the million.
So now that we have both of our options, what are we gonna pick? I think we should pick option 1 because there's a 90% chance that we'll get $1 million, and it also gives us the best expected value of $900,000. However, there is still that 10% chance that the psychologist is gonna be wrong, but I think our chances are better than if we took option 2.
I am going to take option 2 because I'm going to bet on the 10% chance that he was wrong, and I'm going to walk away with $1,001,000.
Steve, however, has a lot of gambling debt to pay off and is kind of irrational right now. Any rational person, though, is going to take option 1. So, in short, expected value is the sum of all probabilities of an outcome. You can use expected value all the time in your life. One great example is the next time you're at a casino, don't place all your money on black. Maybe look at some other games that might give you better expected value.
No. Put it all on black.
Or put it all on black and lose your kneecaps. It's up to you.